Hey everyone! So this tutorial is called Types of Chemical Reactions Part 1. And we're going to be doing several different types of chemical reactions, so I'm going to split these up into different tutorials. So this first one is about the first two types of reactions called synthesis and decomposition reactions. And in your textbook, we're into Chapter 6 now, about midway through it, and the reference for these two types of reactions is 237 to 239. So let's begin with looking at synthesis reactions. And this little cartoon kind of gives you an idea of a synthesis process happening. So we start with this skinny, scary looking bird here, and when the bird eats the worm, we put those together and we create a nice big happy fat bird. And so what we're doing here is putting two things together to create a larger object. So you can see that that relates to an actual synthesis reaction in a chemical reaction where we're taking two things and putting them together to produce one. So in this diagram right here, we have A plus B produces AB. So think of it, you're taking two separate things, those might be two atoms of two different elements, and you're putting them together to produce something bigger, a compound over here, AB. Now, if you look at the second diagram, this is an actual chemical equation. Here we have three magnesium atoms. Okay, so here's our magnesium. And if we combine that with one molecule of nitrogen, to see the reactants right here, they will combine to produce a much larger molecule, a compound of magnesium nitride. So they're all chemically bonded to each other and they produce this larger structure. So this is an example of a synthesis reaction. So now you try it. If you look at these two reactants, what product or products would be made if this were a synthesis reaction? So we're starting with potassium, and that's K, and we're adding to it chlorine. So we'd put like chlorine gas with potassium metal. What would it produce? So take a moment and think about that, and maybe you can write your answer down. So hopefully you came up with combining potassium with chlorine would give you a molecule of potassium. There's our metal. I'm going to run out of space. Potassium chloride, and we're going to change the ending to "ide" because it is an ionic compound. And that we would crisscross their charges. They both have a charge of 1, and we would get KCl. And ultimately I would want you to balance this. So our next step would be to look at this and balance it, and I would see that I need a 2 here and I need a 2 here. So at this point I just want you to be able to figure out what the product would be, and even if that just means using the word, that's fine. But ultimately we will be converting all of our word equations into skeleton chemical equations and then balancing them. So we might as well practice that when we can. So now we'll talk about this second type of chemical reaction called decomposition reactions. And we have this cute little graphic here just to show something breaking down and producing two new products. So we start with this egg and it's cracking up and it produces this cute little baby turtle and some cracked eggshell. So just like in chemical reactions, we start with something big and complex like an ionic compound, let's say, and it breaks down into its parts. So we would have AB breaks down to A plus B. So maybe we have a compound with two different elements together, and it breaks down into, let's say, a metal and a non-metal. Here are two examples of decomposition reactions. So in this first one we have copper 2 chloride, so that's right here. Here's our compound, and it's breaking down into its parts, so it's breaking down into its elements. We have copper metal, and then we have the chlorine gas over here, the Cl2. So there's a simple decomposition of an ionic compound. The one below here, the second one, this one is a little bit more complex because we've started with limestone or calcium carbonate. It's a much larger molecule than the copper 2 chloride was, and it actually breaks down into calcium oxide, also known as quicklime, and you get CO2 gas produced. So sometimes if you have a large compound, it's going to break up into two smaller compounds. We can see in reaction 1 it's breaking up into its elements. In reaction number 2, that large limestone or calcium carbonate is actually breaking down into two smaller compounds. And here's just one more example. It's a common one. If you pass electricity through water, it's a process called electrolysis. Water will split up into its components. It splits up into hydrogen gas and oxygen gas, and you can see that in this graphic. And this last example is a really tough one here. We have some ammonium dichromate, and if you ignite that, you can see the reaction happening in the middle of the diagram. It actually produces nitrogen gas, some water, and Cr2O3. I'm not even quite sure what Cr2O3 is, but your end product looks quite different afterwards. This is not a reaction that I would try in the lab because nitrogen gas is not something I want to be generating in the lab, but you can see that there's actually 3 products made from one compound. So this, you won't always know what's produced in more complex reactions. We'll stick to the simpler ones, but you should definitely know that a compound breaks down into its smaller parts in a decomposition reaction. So now here's one for you to try. If we look at this reactant, sodium oxide, what product or products would be made in this decomposition reaction? So we start with sodium oxide. What would be produced? Take a couple seconds to think about this and try and write down your products. So hopefully you came up with the idea that the sodium oxide is going to split up into its separate parts, and it's going to produce sodium. So we have our metal here, sodium metal. And then what would the oxide become? Well, it would become oxygen. And so we would have oxygen gas. And we don't write it as oxide because oxygen is only oxide when it's in a compound like here. When it's by itself, we just call it oxygen. Let's write a skeleton equation for this. So our sodium oxide, we need to crisscross charges. So Na is 1 and O is 2. So after crisscrossing, I get Na2O, and that's going to produce sodium metal. Now remember that metals exist as single atoms when they're by themselves, and oxygen gas. And hopefully you remembered that oxygen gas is O2. We would now need to balance this. So I need to put a 2 in front of Na2O to balance out my oxygens. That gives me 4 Nas. So I need 4 Nas right there. So again, this is what we're building up to, is being able to write a balanced chemical equation, but you do need to know these types of reactions in order to figure out what the products will be. So that brings us to the end of this video. We'll be practicing these types of reactions in class by writing word equations and balanced chemical equations, and the next video is going to be about the next 2 kinds of chemical reactions, single displacement and double displacement. So that's all for now.